So today we are going to start with the first unit, that is the graph theory, and the topic which I am going to cover in this slides is the graph of a network, its definitions, planar and the non-planar graphs, and isomorphism and tree, right. So in the previous lecture one topic has been left, so I will just cover it. The dependent sources are basically shown by a diamond sign, while the independent sources are shown by the circle, right. So these are the dependent sources. First one is the voltage controlled voltage source. This is the voltage controlled, C stands for the controlled, and the voltage source, that is VC Vs, right. So it has been shown by a diamond shape, and this plus minus sign is showing that it is a voltage source, and since the denotation which shows that it is dependent on kV, k is some constant value and this is the voltage. So it is a voltage source having a plus minus sign shown by this, and since it is depending on the voltage, so it is a voltage controlled voltage source. Similar way, it is a current source, it is shown by arrow, right, and the dependent value is the voltage. So it is a voltage controlled current source, right. The third one is the current controlled voltage source, plus minus sign is showing that this is a voltage source and the dependent value is I. So it is a dependent on I, so it is a current is controlling it and it is a voltage source. The fourth one is the current controlled current source, so it is having a sign of arrow, it is showing that it is a current source and its dependent value is I. So this I is the controlling it, so it is a current controlled current source, right. So these are the different sources which I have covered. Now starting with the first unit, it is the graph theory. So in the syllabus, the prerequisite things which you should know is the basic circuital law, mesh and the nodal analysis, which I have already covered in the previous lectures. So the things which we are going to cover in this is the importance of the graph theory in the network analysis, graph of a network, which in this slide which are we are going to cover this graph of the network, definitions, planar, non-planar graphs, isomorphism and tree, right. So the first topic is will be covered after the completion of this whole unit. So why we are going to study it and what is the importance of it in the network analysis. After studying the graph theory, we will just go through it. So starting with the graph theory, it is basically a study of the graphs which are geometrical patterns of a network, which is going to be the good network analysis, your networks, your circuits, and no distinction is made between the different type of physical elements of which it is composed of. Basically, it is a geometrical pattern of a network and we can't distinguish between the which elements it is composed of, right. So the graph in this context is made up of vertices, which is also called somewhere as nodes, which are connected by branches, right. So branches could be your links, lines, and somewhere it is written as edges also. So it is basically graph is composed of nodes and links or branches. So basically branch is what it is representing the network element, which could be a voltage source, current source, resistance, inductance, capacitance, any network element which is composed, it is represented by a line. This is called the branch, link or edges, while the voltage and the current sources are represented by its internal resistance. As we have already seen, voltage source having an internal ideal voltage source having an internal resistance of 0, while the current source internal resistance is infinite. So for the voltage source we will short circuit it, and for the current source we will just open circuit it. Now node, what is the node? Node is the intersections of two or more branches. When the two or more branches is going to get connected, it is the intersection point. This is called the nodes. It is also called vertices. So for example, if this is a network given, since we are showing that this is a voltage source, resistance, inductance, resistance and inductance, the capacitance is also there. So these are the different elements connected in this fashion. This is a whole network. This is the graph of it. Which is shown by this. Since each element has been represented by a line, no values, nothing will be indicated, only each element has been represented by a line. This is called the branch. Now the voltage source, each elements, see resistance, inductance, resistance, every element is shown by a line. Now this voltage source, since it has to be replaced by a internal resistance, so it has been short circuited here. So this is the graph of it. Why it is called the undirected one? Because there is no sign has been shown where the current flowing or what. So it is when there is no direction of any current is shown, this is called the undirected one. Similarly, this is the similar graph in which there is a direction shown here, so it is the directed graph, right. So in what way we will start? We just give a number to all the nodes and the branches. See, this is the node because it is connecting this branch and this branch. It is the connection of 3 branches, so it is node number 1, 2, 3 and 4. In this way we will just number the nodes, and in a similar fashion we just number the branches also. This is the branch number 1, this is the branch number 1, 2 branch, 3rd branch, 4th branch, 5th and the 6th one. So this is how we denote the whole graph with nodes. For nodes it is 1, and for the branches it has been shown by some brackets with a 1, right. This is the undirected graph and this is the directed graph. The difference between both is, it is having no sign indication of the flow of current, it is having an indication with the arrow, which is we will assume where the direction should be, right. So this is the way to how to draw a graph. Now next is some basic definitions of some parameters or some terms which we are going to be used in the graph theory. So first one is the subgraph. Basically a subgraph is a subset of the branches and the nodes of a graph. It is just a part of that graph which we call it a subgraph. Now what is the connected graph? If there exists a path between any pair of nodes, it means ki all the nodes should be connected with some branches. For example, if you go to the previous slide, as you can see, this node is getting connected with this and this one also, right. So there are 4 nodes, this one node is getting connected with the other 3 also, this second node is getting connected with 1, 3 and 4. So in this way all the 4 nodes are getting connected with each other. So this is called the connected one, right. When there exists a path between any pair of nodes, means all the nodes should be connected with the other nodes, then it is a connected graph. While the disconnected graph is if there is some nodes where doesn't exist a path in any pair, it is called the disconnected one, just opposite of the connected one. Now what is the planar graph? It is a graph which can be represented on a plane without crossing 2 or any other branches, right. For example, if you see this one, all the nodes are getting shown by the number here. Now the branches are also shown. As we can see, it is a graph that is represented on a plane and no any branches are getting crossed each other, right. No any branches are getting crossed. See, this is not this branch is not crossing any other branches, this branch is not crossing any other branch, this branch is also not crossing any other branches. So this can be shown in a plane. So this is a planar graph. Now the non-planar graph is the one which cannot be represented on paper and without crossing other branches, means it is something 3D graphs which can't be expressed in a 2D plane, right. So this is the example of the non-planar graph. We can see that here this branch and this branch are getting crossed, this branch is also getting crossed. So this type of graph cannot be shown in the 2D plane, so it is the non-planar graph. Now rank of the graph is determined as n minus 1, where n stands for the number of nodes of the graph, right. So this is the formula or this is the equation by which we determine the rank of the graph. Now the second definition, now the next definition is of circuit or loop. What is the circuit or the loop? It is particular subgraph of a graph at each node of which are incident exactly 2 branch of the subgraph, right. So for example, if we see here, it is saying that it is a particular subgraph of a graph, it is just a subset of a graph. At each node there is only 2 incident branches of the subgraph is there, right. So for example, this is the previous example only which we have taken. Here there are 1, 2, 3, 4 nodes and the branches is shown by this kind of thing. 1, 2, 3, 4, 5 and 6. So, branches are 6. Now, the rank of the graph is n minus 1, here n is 4. So, 4 minus 1, that is 3 is the rank of the graph. Now, what is the circuit or the loop? It is the subset or the subgraph of a graph. At each node there is exactly 2 branches of the subgraph, right. So, for example, it is taking 4, 5, 6. If we take only the 4, 5, 6 branch, it is like, it looks like this, 4, 5 and 6. This is node number 2, this is node number 3, this is node number 4, this is branch number 4, this is branch number 5, this is branch number 6. So, we can see that each node is having only 2 branches, 2 incident branches. Each node will have only 2 incident branches. So, this will constitute a loop, or we can say it is constituting a loop also, or a circuit also. It is getting be closed, right. In the next 1 to 5 is also constituting a loop. 1 to 5, it look like this, 1 to 5. This is node number 1. This is node number 2, this is node number 4 and this is branch number 1, 5 and 2. So, each node is having 2 branches which is going to be incident, means this 2 branches is connected with one node. Each node will be having 2 branches, exactly 2 branches which constitute a loop. So, this is the way by which we can form a loop. This is loop, this is loop, this is loop, this is also a loop, and similarly this bigger one is also a loop or a circuit, right. Now, when there is a comparison between the graphs, we can say it is equal or it is identical. In the graph theory, some other term is for comparison. It is the isomorphism, right. Isomorphism says that 2 graphs are only identical, or we can say isomorphic, when this 4 properties, when this 4 conditions is going to meet. First one is the number of vertices in both the graph must be same. We have to compare 2 graphs. So, this 4 conditions should be met, right. So, the first condition is the number of vertices or nodes. It could be also nodes, it can be called as nodes also. So, the number of nodes or vertices in both the graph must be same. This is the first condition. Second is the number of edges. Edges is also called as branches, links or lines. So, the number of edges in both the graph should be same, right. This is the second condition. Third condition is the degree sequence of both the graph must be same, and the fourth condition is mapping. This two we will see with the example, it will get more clear. This number of vertices, number of branches must be same. This is the first 2 prior conditions, right. So, we are just going to compare 2 graphs and we will say whether it is isomorphic or not. So, this is the graph A, this is graph number B, right. So, we have to tell whether this A and B graphs are isomorphic or not. So, we will just compare. First condition which we have seen is both graphs should have same number of nodes, right. So, we will just count the number of nodes here. A have 1, 2, 3 and 4. So, there are vertices in A graph is 4. Similarly, B having 1, 2, 3 and 4. So, vertices are also 4. So, the first condition is meeting because this 4 and 4 is equal, right. The second one is the number of branches should be same. So, we will just count the number of branches. This is 1, 2, 3, 4, 5. Number of branches is 5 in A graph, and the number of branches in B we will count as 1, 2, 3, 4, 5. So, number of branches is also going to be same. So, this 2 criteria is getting met. Now, we will come to the third one, which is the degree sequence, right. Degree sequence of both the graph must be same. What does degree sequence says? We will just see it. Degree sequence says that this A node is getting connected with 1, 2, 3 branches. So, this is the degree of this A node. This node is getting connected with 3 branches, so the degree is 3. Similarly, this B node is getting connected with 1 and 2 branches, so its degree is 2. This C node is getting connected with 2 branches, so its degree is 2. Similarly, this D node is getting connected with 1, 2, 3. this is the degree of each node. Similarly, we will just put the degree of the graph B. It is having 1, 2, 3. So, x node has 3, this also have 3 degree, this has 2 and this has 2. So, the degree sequence says that the sequence we can arrange it in ascending order also and the descending order also, means we have to just arrange this degrees in sequence. It could be ascending order also and descending order also. So, it could be this graph A have the degree sequence of 3, 3, 2, 2. We are going to take in the descending order, this is 3, 3, 2, 2. Similarly, for the B figure, the sequence degree sequence will be 3, 3, 2, 2. Higher order has been taken first and the lower is second. So, the degree sequence we can see it is having 3, 3, 2, 2 and the degree sequence for the B graph is also 3, 3, 2, 2. So, this degree sequence is also going to be same, that is 3, 3, 2, 2, and for the B figure also the degree sequence is same. So, this 3 condition is getting matched. Now, the last one is the mapping, right. So, if the 4 conditions met, then only we can say that these 2 figures are isomorphic. The last condition is mapping, right. So, we will just map each node with the nodes of the respective plots, right. So, if we see here in the A figure, we have the nodes A, B, C and D. For the B figure, we have node X, Y, Z and W. We have to just map it whether this is getting mapped with X, Y, Z or W. Similarly, B can be mapped with any of these nodes and similarly C and D. So, we have to just map the node of first A plot, A graph with the second graph. We have to just map it. So, we can start with this way. This A is having the degree of 3, right, degree of 3. Now, we have to see the degree of 3 is having with X also and the Y also, right. Now, we will see this A is getting connected with a node which is having 2 degree, this A is getting connected with the node which is having 3 and this A is getting connected with 2, means A is getting connected with 2, 3, 2, right. So, it should have a degree of 3 and it is getting connected with the nodes which is 2, 3, 2 degrees, right. So, we have to just see for the respective or corresponding nodes which having the same sequence, right. It should have 3 and it should be connected with the degree sequence of 2, 3, 2, right. This X is having 3 nodes, sorry, this X is having degree of 3, this Y is also having degree of 3. So, we will take just this one. Now, this should be connected with the degree of sequence of 2, 3, 2, right. This is connected with 2, this is connected with 3 and this is connected with 2. So, the degree sequence is getting also matched, right. So, we can say this A is getting mapped with X node. This A node of this A graph is mapped with the X node of this B graph, right. So, in this way, similar way, we can map all the nodes of graph A with the B graph, right. Similarly, this B is having 2 degree and it is connected with 3, 3 and 2. So, we will just check for the degree 2, it means we have to map with Z and W only because it is having degree 2, right. So, it should be connected with 3, 3, 2. It is, if we take Z means B is getting mapped with Z, then it is getting connected with 3, 3 and 2. So, B could be mapped with Z. Similar way, this C having degree of 2 and it is getting connected with 3, 3 and 2. So, it will be only this W is left. So, this C is getting mapped with W because this C is having 2 degree, W is also having 2 degree. It is connected with 3, 3, 2. This W is getting connected with 3, 3 and this C is getting 2 and it is connected with 3 and 3 only, right. Similarly, this W is getting connected with 3 and 3 only, no 2. So, this is mapped with X is mapped with W. Similarly, this D is getting having a degree of 3 and it is getting connected with 3, 2 and 2. So, this D is getting connected by Y, it is having 3 degree and it is connected with 3, 2 and 2, right. So, it is mapped with Y, right. So, this is the mapping happened. A is getting mapped with X, B is getting mapped with Z, C is getting mapped with W and D is getting mapped with Y. So, this is the mapping happened. Now, we will see whether the between the nodes the branches are also getting same sequence or not, means A and B is having any branch or not. So, A and B, if we see here, if we see here, if we see here is A, this A is connected with B, C and D, right. A and B is getting connected with A and B is having one branch only. So, we have to see whether X and Z having one branch or not. See, X and Z having one branch, right. Similarly, B and C is getting connected. No, there is no branch connecting B and C. So, Z and W should have no branch. So, we can see Z and W is not having any branch. So, this condition is also mapping. C and D is having a branch. So, whether W and Y have branch or not, we will see W and Y, they have a branch. So, respective of all the permutation combinations, we will see A and D is having branch. So, X and Y should have a branch, X and Y should have a branch. So, in this way we will see the mapping is getting completed, means A is mapped with X, B is mapped with Z, C is mapped with W and D is mapped with Y, right. So, in this way we can say the vertices are going to be same. Second condition, the branches, number of branches are going to be same. Third, the degree sequence is also getting same, and while we mapping is also getting mapped, all the nodes of the A graph and the B graph are mapped, and the number of branches between the two nodes are also getting same while mapping. So, we can say that it has mapped completely, right. Mapping is also done. So, all the 4 criteria, all the 4 conditions are getting completed. So, we can say yes, A graph and the B graph both are isomorphic. So, by having this concept only, we can identify the isomorphism property or comparison between the 2 graphs. We can easily say whether it is very complicated graph also, we can say whether it is isomorphic or not. Now, the next definition, now the next important definition is the tree. It is basically a set of branches with every node connected to every other node, means each node will be connected with other nodes directly or indirectly, such that the removal of any single branch will destroy this property, that each node should be connected with every other nodes directly or indirectly. If any removal of the single branch is done, then this property, connection property between the nodes will be destroyed, or in the other words, simple way we can say that it is a set of branches containing all the nodes. If there are 4 nodes in a graph, then all the nodes should be there, but there is no closed path, right. There is no closed path between the set of the branches. So, we can say it is a tree. We will see with the example. We will just take the previous example only. This is the graph which we have taken from the network. So, in this way we have 1, 2, 3 and 4 nodes. So, for a tree, one node should be connected with all the 3 nodes, right. So, we can say कि if we take 1, 2, 3 and 4, 1, 2, 3 and 4 nodes, and if we take the branch number 2, 4 and 6, right, 2, 4 and 6. So, this 2, 4, 6 branches are getting connected with all the 3 nodes, all the 4 nodes 1, 2, 3, 4, and it is not closed also, right. So, it is a tree. So, there are innumerable way to write a tree. It could be any combination, it could be like this also, it could be 3, it could be 3, 2, 4, 3, 2, 1, 4 by taking the branches 4, 2 and 1. So, tree here is 2, 4, 6, this is one tree. This combination is constituting 1, 2, 4, this is the second one. The main basic properties of a tree is it should have all the nodes and there is no closed path between them, right. So, for another way we can say 1, this one, this is node number 3, this is node number 2, this is 1 and this is node number 4. This is also connecting all the nodes and there is no closed path between them. So, we can say this is branch number 3, this is branch number 2, this is branch number 5. So, 2, 3, 5 are one tree. So, in this way we can say it will have a tree which is connecting all the nodes and there is no closed path between them. So, the number of tree branch means a tree having a branch will be always n minus 1, that is n is the number of nodes, n minus 1. See, there are 4 nodes, the tree branch will contain always 1, 2 and 3 number of tree branched. So, it is always 3 for this graph and it is equal to the number of KCL equations which could be written for this graph. Okay. So, this topic, this slides or the lecture number 2 has covered all the parts which is the basic definitions we can say. It is containing the graph theory of networks, definitions, planar and non-planar, isomorphism and the tree. In the next lecture we will go to see co-tree, links, what is the topics left, we will cover it in the next lectures. Thank you.